Hello, and welcome back to CS631 Advanced Programming in the Unix Environment. This is week 5, segment 10, and we'll continue to try to fix our broken code. I know, story of every programmer's life. But that's just the point, we want to get better at debugging code, and so we will practice using a debugger. In our last video, we fixed the seg fault in our simple-ls program that resulted from us foolishly not checking the return value of a function that might return null on error. Now, let's see if we can also fix our flawed Fibonacci sequence program. Remember, when we last left the program, it looked like this. And when we ran it, it seg faulted. So, now let's run this program in the debugger. We know GDB will immediately tell us where the error occurred, right? So, let's run it. There, seg fault in fib on line 6. But this time the error is not quite so obvious at all. So rather than letting the program run and fail, we'll this time observe the program while it is running. Here's the program again. So let's start by setting a breakpoint right at program startup in the main function. A breakpoint means that the debugger will stop the program from executing when it reaches this particular point, but the program is not terminated. It's really just paused, and we can inspect the program at that point. Okay. So we run it again, and here we go. The program starts, and when it enters main, we are given control. If we want to see the code as it's being executed, we can switch to this display by hitting Ctrl+X(O), and we'll be able to see exactly which line we're on as we're stepping through the program. Right now, we're over here in line 16, checking argc. If we type n for next, then we move on to the next statement, which is the printf on line 21. Now, if we let the program continue uninterrupted, we'll again hit our seg fault in fib. So just letting it run didn't really help us. Let's try again. We'll add another breakpoint at the function fib, meaning we'll pause now every time we enter the function. Let's see what our current breakpoints are. Info breakpoints. 2 breakpoints, one in main and one in fib. Okay. Here we are. We enter main. Next. Now we're on line 21. Next again, and we're in our first invocation of fib with I equals 7. We hit next, and then again, and we now begin our recursion. We are calling fib with I equals 5, I equals 3, I equals 1, I equals -1, I equals -3, and so on and so on and so on. It looks like this doesn't end. Info breakpoints now shows us that we have hit breakpoint 2 15 times, meaning we've called fib 15 times already. So that doesn't seem right. Look at our condition up here. We never hit the base condition of I equals 0, because we started with an odd number and recursively called fib I minus 2. But the Fibonacci base condition is not only fib 0 equals 0, but also includes fib 1. So let's add that case here. There. Now we've added a check for I equals 1. Let's try again. So now that's not right either. We get back 0. Back into the debugger. Let's look at the code again. We can set breakpoints not just by function names, but also by line numbers. So let's break here on line 21. Again, we get our code display, and then run the program. Here we are. Now, instead of calling next, which would try to move on to the next statement in this function, we call step to, well, step into the next function we're calling. Okay, back in fib, I equals 7. Hitting return repeats the last command, so another step. And so, again and again, we enter fib with I equals 5, 3, and then 1, then returning. Then calling fib from the second part of the return, and so on and so on. But as we step through this, we see that no matter what we do, we will now always return 0 eventually, which is why our final result, adding 0 and 0, is of course also 0. So we need to fix our base condition once more. For the base case of 0, we need to return 0, but for the base case of 1, we need to return 1. So we can change this over here to return I. Now, let's compile. And here we go. fib7 yields 13, yay! Let's see if it returns the right numbers for 0 through 10. Yep, that looks about right. Hooray, we fixed our program! Okay, time for another break. In this video, we saw that even though the debugger can pinpoint the location where, for example, a seg fault occurred, sometimes we need a bit more information. So to observe a program as it executes, we can cause it to pause execution at any point in our code by setting so-called breakpoints. We can have multiple such breakpoints in different places in the program, and we can set them by function name or line number, for example. When the program reaches the given location, it will be suspended, and we get dropped into the debugger's command prompt, allowing us to then inspect variables within the current execution scope. Once we are at a given breakpoint, we then use the next command to move to the next instruction in the current function, or we can use the step command, which may step into a function that is being called. All the while, we can use the visual display to show our code as we are moving through it, thereby allowing us to better visualize the execution. Altogether, this lets us identify and fix issues in our code that otherwise might be harder to track down. But of course, there's still plenty more that we could do with our debugger, and in our next video we'll look at yet another failing program in desperate need of being debugged. Stay tuned, and thanks for watching. Cheers!